Right. Hi, everyone. Welcome to the NIST Differential Privacy Synthetic Data Challenge webinar. It's a pleasure to have you here. We're just going to give everyone a few more moments to hop on, and then we'll go ahead and get started. While we're waiting, it would be great to know who we have on the call. So if you're here, you'll see a chat in the bottom bar, and please feel free to introduce yourself. Love to know where you're from. We'll do some introductions of the panelists in just a moment. Okay, so my name is Kyla Jeffrey. I am the Director of Challenge Success at HeroX, and I'm thrilled to be here with everyone to moderate this webinar with the NIST and Topcoder teams. I'd like to pass it over to Christine Task for an introduction into you.
My name is Christine Task. I'm the tech lead on this project. I did my dissertation with Chris Clifton at Purdue on differential privacy and social network analysis. And I'm very excited about the problem we're looking to tackle here, which we're going to tell you a little bit more about. But first, we're going to let Therese Manley from NIST tell you why this is an important problem that they are interested in looking into.
Awesome. Therese, do you want to introduce yourself? And then we'll hand over the introductions to Doug and get started.
Sure. Thank you, Kyla. Thank you, Christine. My name is Therese Manley, and I represent NIST, who is the National Institute for Standards and Technologies. We are a government lab that supports various things for the federal government. The particular area that is supporting this challenge is the Public Safety Communications Research Lab, and we'll talk about that in just a few minutes. I am a prize manager, and we support prize competitions as a way to support the research that is occurring in our division. Grants are also another way that we support our research, so prize competitions is a rather new way for us to support our research.
Great, thank you, Therese. And Doug.
Hi all, I'm Doug Weinheimer. I'm a challenge architect at Topcoder. So I'm responsible for all of the submission processes and processes behind the challenge itself.
Great, thank you, Doug. So here's what will happen on today's webinar. Our goal is that you get a really good understanding of what this challenge is about, how you can participate, and we can also answer any questions that you have. So we'll start with a short introduction from Christine and Therese, walking through the challenge, why it's so important, and how it works. And then we'll open it up for a Q&A discussion. So while we're going through, please do submit any questions that come to mind. You'll see there's a Q&A box on the bottom there. Please submit your questions in that box. There's also a chat feature that happy to have you use and talk with fellow participants and panelists, but please do keep your questions in the Q&A box so we don't miss any of them. And with that, I will hand it over to you, Therese.
Great, thank you, Kyla. And welcome everyone. We're very excited that you are participating or planning to participate in this challenge. As I mentioned, the Public Safety Communications Research Division is a division of NIST, and we are responsible for the sponsoring of this data science competition. We are looking at ways to help advance the research for our America's first responders. This particular challenge is data science and data analytics. There is so much, as you know, the flood of data that is coming into all avenues, whether it be in a network operations center or whether it be for law enforcement and criminal activity. So we are trying to get a handle of the flood of data that is coming into our data centers and with our first responder operations. We hope to be able to find more avenues to really make our first responders safe and have them support safety and security in our communities, which is, paramount to everybody in our community. And then also help to inform that decision making and increase the response time to activities or incidents that may be occurring. The wildfires out in California are a perfect example of ways that we might be able to utilize some of the information that we're getting on a minute-by-minute basis and improve the lives and help our first responders in incidents such as that. but we must assure the data privacy and security of personal information. And that is kind of the basis of this competition. So I'll go ahead and hand it off to Christine Task, who is our project lead on this competition, and she'll explain more about data privacy and differential privacy.
Hi, so I imagine many of you are already familiar with differential privacy, but for those of you who are not, we're going to talk about that a little bit and why we are looking at using differential privacy for this. So essentially, give me just a second while I get used to the variety of windows that this webinar system pops up for me. Okay, so previous techniques, things you might think you would want to use if you have a data set that you want to release for public analysis would be anonymization. And in fact, both of the data sets that we are looking at using over the course of the 6-month contest are real data, real sensitive data over real people that have been anonymized. So names have been blocked out, addresses have been blocked out, things like that. But what we've found is that actually a lot of times this data can be de-anonymized if you have some outside information. It's actually possible that even though there's no name or no address, if there's enough unique characteristics, if you know a little bit of background information about somebody, you can still find their row in the database. And once you've done that, you know all the rest of the information in that row, so all of the sensitive information about them. And there's a variety of techniques that were developed to try to avoid this. So maybe if, you know, no row is unique, maybe if we have duplicates of everything, at least K of each possible row, then we'll be fine. Well, it turns out that that has leaks too. It can be possible to infer sensitive characteristics. If I just know that this person, the person I'm looking for, is one of these K rows, and all K of those rows share some sensitive characteristic in common, then I've invaded that person's privacy. So what differential privacy does for us is, rather than being any specific technique, it is takes it from the other direction, and this is a guarantee. It is a guarantee that given the data set, and given the data set with some arbitrary person removed, if I go through whatever I'm going to do to process the data, the thing that comes, in general, we are looking for randomized processing techniques now. We're going to add some noise. We're going to do some screwing with things. The thing that comes out from the data that has been processed with that person in the data set, the thing that comes out with the data that has been processed without that person in the data set, should have overlapping probability distributions. And so that means that any given value that comes out of my processing system should have a relatively similar chance to have come from this data set as from the data set with the arbitrary person removed. That means I can't track things back down to individual people. And that's a nice, solid guarantee, and it's about the best we can actually do. There's a good reason why anything really much more solid than that suddenly makes it impossible to release any information at all. And so now that we have this solid guarantee, we start looking at different ways of achieving it. So first of all, we'll talk a little bit about that. Okay, but the nice thing about having a solid guarantee is that it is a good goal to shoot for, but we have to achieve it, right? We have to find ways that can privatize this data, that can generate synthetic data sets that resemble the original data while still satisfying differential privacy, and actually produce synthetic data sets that are usable for the tasks we need to perform. And so public safety is interested in this, and you'll notice that the first data set we're using is actually a data set of 911 records, fire emergencies in San Francisco, because being able to publicly share synthetic data for public emergency type scenarios enables us to discover patterns that improve our usage of public resources for addressing these disasters. But obviously it's incredibly sensitive data. So that is what we're looking at this. And this is a great slide to tell you a little bit more about differential privacy. So privacy preserving data algorithms. Basically, what we're looking for with synthetic data is these overlapping probability distributions. And what this does essentially, like I said, is blur the data. So given the real data and the data that is just a little bit edited, things are blurred enough so that we can't tell which one is the true case. What I'm going to say here is that in a given webinar, in the 5 minutes I have to mention this, if you came in and you're listening to this and you've never heard of differential privacy before, you may have a little bit of an idea what we're talking about now. If you've got a good math background, you can look at this formula and it'll give you some more information. But it's not going to be enough to compete. So what we have for that is there is a series of tutorials by experts in the field that we can post. There has been on the Topcoder website already, and if you need help finding that, we'll send out information about that. There are resources, a series of relevant papers, tutorials, websites, and so on, survey papers that will help get you up to speed. And that is really the way to go look at it, because it can be a relatively complex thing. But this is basically what we're talking about with overlapping probability distributions. And we are specifically, I want to make sure this is clear, this is why it's in the name of the challenge, we are only looking for solutions that can produce synthetic data that satisfy differential privacy. So there's many ways to produce synthetic data. Multiple imputation, there's lots of other approaches out there, good anonymization schemes, but that's not what we're looking at for this challenge. For this challenge, we are pushing the bounds of differential privacy. And so we are going to be doing a series of checks to make sure that all submissions satisfy differential privacy. Okay, we're going to tell you a little bit more about the overall challenge. So in stage one, so there's already been a stage one here. We just asked for sort of ideas about good differentially private synthetic data algorithms. And the idea here is that given a real data set, can you build a sort of a model capturing the distribution of that data set one way or another? There's many ways to approach that, but in such a way that the process is differentially private, and then use that to generate a new data set, a synthetic data set full of fake people. There's no real people in there, and because we've satisfied differential privacy, there's no way to re-identify any information about any real person in that synthetic data. And that synthetic data can be released. Of course, the easiest way to do this is to just produce random data, obviously. So the thing that we're looking at is that the synthetic data should capture most of the important distribution properties of the original data, so that analyses on the synthetic data hold true, are useful for drawing conclusions about the original data. And so in our first challenge, we just had people kind of produce ideas. There were write-ups and things like that, and we got some very interesting results. And we awarded a total of $40,000 to the winners of that competition. In the second one, we're actually going to be checking to make sure that that synthetic data behaves like the real data. And we're doing this in a set of 3 marathon matches. And this is the first one right now that we're in the middle of. And so the marathon matches are 5 weeks in length. Each marathon match is going to have a data set that they're using and a particular type of scoring. And the scoring is going to get sort of more difficult or interesting as the match goes on. In the first match here, we're just sort of looking at basically general distribution properties. We're going to be looking at marginals. In the second one, we're going to be looking at classification tasks. And the third one, we're going to be looking at regression tasks. Here in this first match, we are using San Francisco Fire Department incident data. In the second and third match, we are going to be starting to use American Community Survey data from the census. Let's see. And there is, for these 3 matches, a total prize purse of up to $150,000. So that is the total amount of money that we have available for people who have good solutions to these problems. Now let's talk a little bit more about how all of this works. Okay, so in the marathon match, and this is a Topcoder match. This is one of their, this is a typical top coder competition with a few adjustments to make it work for us with differential privacy. But the way it works is there are two basic phases. We're in the middle of the first phase right now, which is the testing phase, the provisional scoring phase. And what that means is that when this webinar gets done, if you've registered with the Top Coder system, you have an account, you can go ahead, run your synthetic data algorithm on the code, on the data that's available for you there, submit your results, and immediately get a score and be on the leaderboard. And the last time I checked, we only had 2 scores on the leaderboard, and one of them was an error of -1. So if you have a system that produces synthetic data and you want to try it out right now, you can end up on that leaderboard. You can submit every 4 hours. So you submit, you get a score, you make some tweak or improvement, you can resubmit and see how you do. And you have several more weeks to do this. This wraps up at the end of the month, November 29th. And that's basically what the testing phase is. This is for you to refine your algorithm and climb up that leaderboard. During this phase, though, because I think everybody here, if I say what the easiest way to climb up that leaderboard is, it's just to return the original data, right? It's not to do differential privacy at all. So we actually have during here a pre-screen check that you can submit your algorithm write-up and proof. And this takes a little bit longer than just getting on the leaderboard, but this is how you get a lot of points on the leaderboard. So you submit your algorithm write-up and a clear, complete proof that it satisfies differential privacy. And there's plenty of examples of how to do those proofs in the resources we have available. And we have our team do a pre-screen check, which is not going to be perfect at this point. We're looking to make sure you have a basic understanding of differential privacy, you're making a good faith effort to satisfy it, and you're not committing any obvious errors. If you pass the pre-screen, all of a sudden your score on the leaderboard is going to jump significantly. So, and we'll be doing our first pre-screen review for anybody who's already submitted for that. That's going to be later today. So you'll start seeing those go up soon. Once we have gone through this whole initial phase with the testing phase, then we're going to take the top 10 people from the leaderboard and invite them to the sequestered phase. For the sequestered phase, you're going to submit your code because we're going to want to be able to run it ourselves. We're going to do a more thorough evaluation. And your complete write-up on whatever your final tweaked version of your algorithm is and your proof. And we are going to do a careful evaluation for accuracy. We're going to run your code at a variety of values of epsilon, find out where that privacy utility trade-off is. We're going to be doing a slightly different scoring system, different sets of marginals, on a different subset of the FHIR data than we've used before. So we are going to do a thorough evaluation of your code and see where it scores against the other top scorers. And we're also going to do then the final thorough review to make sure that you satisfy differential privacy. And so we'll have several subject matter experts looking through that and looking through your code and doing our very best to make sure that you've actually satisfied differential privacy. The top 5 from those win money. And the next 2 months, we start it all over again. So you'll have another chance to win in January, and you'll have another chance to win in the spring. In fact, here's our deadlines right here. So we are right now in the middle of match 1. Match 2 begins next winter, and match 3 begins in the spring. And I expect things are going to get a little bit harder as we go along, and we pick up more contestants. So right now, anyone who wants to win $1,000, we are handing out our first midpoint award on Thursday to the top 4 submissions. Right now we have 2 submissions, and one of them has a score of -1. So I expect we can actually, there's a good opportunity for anyone who wants to participate. We do have on the website, in addition to all the resources explaining differential privacy, there is also sample code. And it gives you a very naive algorithm. This is just for anyone in differential privacy. It's count up out all the roles, do some bucketing on the numbers, and then add add noise to the row counts. And so it's a kind of the naive algorithm, but it will still perform okay on the data. You can tweak it and do better, and it's differentially private. And if you just want to test out the system, you can try running it, submitting it, and seeing how you score. But I'm hoping we're going to see some teams outperform that. But for right now, it's a good thing to get started on. Okay, and yeah, so here is a list of the exact words we're going to be getting. And I think this is going to be, yeah, the end. We're going to go on to questions here. One thing I want to mention just up front. So there are several parts to this puzzle, right? There is understanding differential privacy and understanding the problem that we're trying to have solved. There is understanding the specifics of our data sets and the scoring. And so if you're familiar with differential privacy, all the stuff you need to know to make sure your algorithm's going to work, make sure specifically what we're going to ask of you. And then there is the specifics of working with the Topcoder system. So some of you will already be very familiar with Topcoder. Some of you are going to be new. If you have any difficulties with sort of any of this, but also especially with the Topcoder system, as far as figuring out how to get your submission up and going, figuring how to get at anything you need to get at, a good place to ask is the forum. So just get comfortable and familiar with using the forum. You can post questions there. People respond to them quickly. Obviously, we're going to answer a whole batch of questions starting more or less right now. But also, if you run into technical difficulties as you go along, I don't want there to be any roadblocks. So forum is your friend. All right. I think let's go ahead and see Kyla.
Awesome. Thank you so much, Christine. I really appreciate that introduction. So what we're going to do now is some live Q&A. So thank you to everyone who's already submitted their questions. That's fantastic. We have them and we'll start running through them. And we also have some questions that were submitted in advance of this webinar. So we'll go ahead and get started. One other point before we do, there may be some questions that you ask that we don't have the answer for right now. And if that's the case, then we'll follow up after the webinar and make sure we get that answer to you. Okay, so Christine, do you mind stopping your screen share, please?
Sure.
Thank you. Fantastic. Okay, so the first question that I have is, how is the data set selected for this challenge? Why is it important? Can you talk a little bit about some of the details and specifics of that data set?
I'm sorry, I'm going to make you say that one more time.
No problem. So for the data set, how is the data selected? And can you talk a little bit about the shape of the data, the size of the data, some of the details?
Yeah, so one thing, anybody who's looked, obviously, I mean, the fire emergency data is very applicable to our public safety use case. If you've actually looked at the data set, you will see it's got categorical data and numerical data. The numerical data is by time. And if you look at our scoring function, we're actually breaking things, numerical values into buckets, sets of buckets, I think of size 100. And so we're only looking for limited precision on the numerical data at this point. And you'll also see that the columns are sorted so that the columns with the fewest number of possible values come first. And the way the scoring algorithm works is you can actually choose to, if you want to, as you're getting ramped up, you can choose to only synthesize a subset of the columns. Say you only want to do the first 6 or the first 8 columns, and the scoring function will sort of give you an increasing score. You'll tend to score higher the more columns you do, but you will still get a decent score even just for doing a subset of the columns. So you can start your algorithm out on a smaller data set with a small set of categorical values, and you can move up from there. And like I said, it's a relatively low granularity on the numerical values. It's only 100 buckets that we're looking at. So you should be approachable, all of this. And that's because we're in the first phase. In later phases, we're going to look at more interesting things with the numbers. But that's the data set we had. We thought that should make it a good playing field for everybody.
Okay, awesome. Thank you, Christine. My next question is probably for you as well. Does the algorithm have to be original? Can the implementation be based on existing algorithms?
The implementation can be based on existing algorithms. We'd like you to cite your work if you're drawing exactly from somebody else, and we need to have algorithm write-up and stuff. But anything that is published out there is fair game. Obviously, if the team that originally published that work would also like to come compete, that would be good too. And in general, then what we basically have, and this is the norm for top coder contests, is you have some core idea, and now people are trying to, over the course of the marathon match, of course of the subsequent matches, trying to make improvements and tweaks and so on as they get feedback to get even better and better performance. And so that's what we are really looking at, and what NIST is interested in is how we can get algorithms that have good practical performance. And I think it's perfectly reasonable to start from a base of published existing things and go from there.
Awesome. This question is similar, and I'm going to ask it to you as well in case there's any additional context. So there are some well-known papers that have solved this problem, and this individual has wrote some of those papers when the data is partitioned between two entities. Can they participate?
Okay, so I'm looking at that one too in Q&A, and that's Dima. So I want to make sure it does need to be differentially private. And I know there are SMC things that are also good. So as long as we're talking about differentially private stuff, and you may be talking about the local model differential privacy, and we are actually, we should be clear here, we are actually looking at central model differential privacy for this. So we are assuming that the data set is owned by somebody, say Census, say the city of San Francisco, and they want to run this algorithm on the real data that they have, the whole data set, and create the synthetic privatized data. So you are absolutely welcome to use previously published stuff that you've written. If you've been working in the local model and you want to take the advantage of the fact that we are assuming the central model, which has should be lower noise requirements for you, and you can adapt some of your work or whatever, we would be very grateful to have you. But right now, we are just working with the central model case.
Great, thank you so much.
And please ask follow-up questions if that doesn't answer what you're asking for.
Absolutely. And now what about the software that can be used for this competition? Can people use R?
Yeah, we have no restrictions against the language that you're writing in. Christine, did you have any?
No, please use R. That's fine.
Awesome. Okay, Therese, this one is probably a good one for you. So my team captain won't play any role in the design of the algorithm, but will handle administrative matters like the payment. Is that okay?
Yeah, so I'll answer this question with also pointing you to the rules. There are the official rules and the contest rules on challenge.gov, and I would encourage you to go through both of those thoroughly. The NIST official rules, in the event there is any discrepancy or inconsistency, those terms and conditions will supersede. And so as far as the captain and the official representative that's talked about in the NIST rules and the captain that's talked about on the top coder rules, those are one and the same. Those submissions should be made by this user, and payments will be submit to that user. Overall, just to talk a little bit about the eligibility, which is in the NIST official rules 3B. The official representative must be 18 years or older and a U.S. citizen or permanent resident of the United States or its territories. That is the person who will receive the payment. NIST does not get involved in how those funds are distributed. So one single payment is made from a cash prize perspective, which is why we request the U.S. tax ID, and we will be requesting bank information at the point in time when prizes are awarded. But the official representative is the person that we'll coordinate with, and that person will coordinate with the team members. And again, NIST does not get involved in the distribution of that. And if there's any other questions that I didn't answer along that lines, please send another note in the chat.
Yeah, there was actually one that came in just as you were saying that. Can non-US citizens participate?
Yes, they may participate as a team member.
Great. Thank you. Okay, now I have an additional question for Christine. How is differential privacy bound epsilon checked on submitted files?
Okay, so we are doing the best we can with this. And the one thing I want to make very, very clear is that before anybody gets any money from the final large prizes at the end of each marathon match, you will have to submit your code to us. We're going to get to look at your code. We're going to run your code ourselves to get the final score for it. And we're going to do a careful evaluation on your write-up, your proof, your code. We're going to do whatever we can to try and make sure that you are playing fair. In the short term, so immediately what we're going to be doing is in the provisional level, before we get up to that final scoring, we have the pre-check. So we're going to say, you need to at least say you're using epsilon correctly. You need to at least have something that should be differentially private, barring some subtle strange error. And if we suddenly see you start outperforming anybody else who has a different private solution, radically, then we can ask you to resubmit your write-up and so on. So we will be skeptical of people who are using the wrong value of epsilon or doing something else that's not really satisfying differentially private. If we see suddenly someone suddenly who passed the DP pre-screen and suddenly they're doing much better than they ought to be, we'll look into it. Is it possible to go ahead and win one of our little midterm prizes before we do the final thorough screening and do it by cheating in some little bit? Probably. Okay, so if that's what you want to do with your life, you can. But in general, for the real money at the end and the awards and everything else we care about, we're going to do as thorough a job as we possibly can to make sure that everybody's playing fair. Okay, that answers your question, hopefully.
Great, thank you, Christine.
So I did see one more real quick, so I just
Absolutely.
wanted to make sure that Therese had made this clear enough. If you are not a US citizen and you want to participate, what you basically need to do is find somebody who is a US citizen to collaborate with, who can be your team captain. And one thing that I don't think we mentioned explicitly, but the Top Coder usually does, is they support forming teams over the course of the competition. And so if you see somebody else on the forums or somebody else, first of all, you reach out to friends, other people you know who are American. They don't necessarily have to be actually telling you what to do, but you need to partner with them so that you have a US person, and they'll be the one that'll be the primary contact. They'll be the one receiving the money and so on and distribute to you. You can also reach out to people on the forums and look for teams there. I think Doug can probably talk more about that if there's questions, or there's already information on that in the rules. So we would love to have non-US citizens participate. We absolutely expect to. But you just got to find a US citizen to join your team.
Great, Thanks, Christine. While we're in some of these more teaming and kind of legal type questions, can we talk a little bit about tax? So Therese, this might be another question for you. Will the entire prize amount be forwarded to other teammates necessarily be considered by IRS as income for the team captain? If not, what's the legal status of this payment and how could this be explained to the IRS?
Sure. Yeah, so as far as tax implications, NIST does not get involved in how the monies are distributed, and we do encourage you to work with your tax advisor in order to properly receive the funds. So it's a very important question. There may be tax implications for you, and depending on what your bank account and accounting codes and information that you give us to make the payment to you, that should be determined prior to you sending us that information. So, everybody's situation is a little bit different, and how those funds are distributed you really need to follow your own tax advisor and tax guidelines for your personal need. And I really, I hesitate to advise any further than that, but it's really important to make sure that's clear, and I think it's a great question.
Great, thank you. Okay, so back to the scoring. In the scoring scheme, is it public with code and a zip file, exactly the same as what's submitted online? And if so, submitting online to check the score is not useful, is what this person is saying. Can you comment on that?
We tell you exactly what the scoring function is. You are welcome to go implement it yourself and run it yourself and see how you do. The advantage of submitting, at least in this match, in the next match it may be a little bit different, but in this match we have, the advantage to submitting is you end up on the leaderboard. And if you don't end up on the leaderboard, then we don't know if you're one of the top scorers. If you don't end up on the leaderboard, you're not eligible for the progressive prize that we're handing out on Thursday. You're not eligible to be one of the top 10 that get invited to the sequestered phase, the final phase. So please submit so we can see how you're doing. But also you're welcome to implement for this match the scoring function yourself and test yourself. And of course, then you can test yourself more than 6 times a day. So I think, Kyla, if you don't mind, I can see this whole question set. Can I just go ahead and go through it?
Absolutely, take it away.
All right. Okay, so submission after the deadline going to be, okay, so when you have to send us your code for if you're one of the top 10 scorers, we ask to see your code for the final scoring in the sequestered phase in December, you keep your copyright. We have to keep your code and everything else secret. We sign NDAs. So none of that's being made public. We are very much looking for open source solutions. And if you win, we will give you a $4,000 bonus if you are willing to put your stuff on an open source repository, because that's what the world needs. Just like we have open source cryptographic protocols, nobody's going to believe that your privacy solution is a good one unless everybody can look at it. But we won't be doing that. We'd like you to make them public, but we will not be sharing things publicly. We will, and you will keep the copyright, all of the IP permissions for your own solutions. I see Teresa's nodding.
Yeah, Christine, there's just one qualification. I know the $4,000 is for marathon match number 3, not 1 or 2. So that is the final prize awards.
Yep. So that'll be in spring. It's when we're looking for the winners, the people who have demonstrated on this general benchmarking that they have effective solutions. They're the ones that, I mean, honestly, everything open source is lovely, but that's the point where we will be asking for if people be willing to open source their solutions. Okay. How much can I refer to the previous paper's proof? Or must I write up my own proof in my own words? How detailed are you expecting? Say level of peer-reviewed conference academic paper. It's a proof. And I would like you to do it in your own words. I would like you to be able to understand and have vetted. If you're using somebody else's algorithm, it's important that you understand the privacy properties of the algorithm and why it's private, so that as you make adjustments to the algorithm, you don't break the privacy. The exception of this, if it is a paper that you wrote, then I'm fine with you referring to the previous paper, as long as in that paper the proof is very clear and complete and easy for us to read. Think painless, be nice to your reviewers. So if it was a paper with a very short page limit and you had to kind of cramp the proof up, we would appreciate the long version. If it was not a paper that you wrote, please do write your own algorithm specification and your own proof and make sure they're clear and complete. And you can ask for helps on the forum with this. And obviously you can copy from the paper. Please do cite the paper. But I would like to see that you've thought through it yourself, just because it's going to be a really important exercise, because otherwise, if it's not something that you can do yourself, you know how this goes, right? Then it gets to be a little bit more difficult to mess with it. Now, this is just my preference on that. Okay, scoring. When partitioning continuous values into 100 buckets, the range is from my data. So the range is from the original data, right? So we have the original data, and you are creating synthetic data, and we're seeing how the two compare. So our baseline here is also always the original data set that you were handed, the one that you were supposed to synthesize. So that the buckets and everything else are all based on the original data. And then we we see how your data compares to those same buckets. Okay, so how do you check the privacy? Okay, let's see. How do you check my privacy? My algorithm is randomized, so it can be luck that we get, presumably, there is a close to 0 chance, but technically not 0, that you run the randomized algorithm and it reproduces the exact same data set again. And if that, by randomly sampling noise 0 for every time you have to add noise. And if that miracle occurs, we will deal with that when it comes to it. But I think in general, if you suddenly, we're checking privacy by having you submit the algorithm right up in the proof and by checking your code at the end in the final phase. If you suddenly start outperforming things, remember you're going to be submitting multiple times to stay on the leaderboard. If you roll really lucky one time and shoot to the top of the leaderboard, and we contact you and we're like, hey, it seems like maybe you made a significant algorithm change since the last time you submitted your code for privacy review. What's up with that? And it turns out when you run your code again, you're suddenly doing much worse. That's kind of going to correct itself the next time you submit to the leaderboard. Okay, hope that answers that question. And then what is the distribution of the set of 30 tuples of columns constraint on each column that must be used at least once? The distribution is no longer, okay. So for doing the scoring, we're just doing marginals. So what that, I think it's described in a fair amount of detail there. But basically what we're going to be doing is sets of 3 marginals. So we're picking 3 columns. And because we want to be able to get your score back to you reasonably efficiently, and we need to be able to do that in a lot of people, we're not doing all sets of 3 columns. We're not doing n choose 3. We're actually just doing a collection of marginals. It's going to be random, and it's going to ensure that each column appears in at least one set of 3. And I think the algorithm online is described in a little bit more detail, or if you want more detail than that, you can always just ask on the forum and we'll be happy to tell you. And so that means also there's going to be a little bit of randomness, but when we ran our own experiments on this, it still seemed to be fine. You'll notice that the scores are going to go all the way up to 1 million. In general, the difference in algorithm performance is more significant than the little bit of random variation we get from the column selection or your noise addition. This is phase 1 of a 3-phase match for a reason. So if we run into any difficulties or issues, anything seems to not be working the way we expected it to, if you have any concerns, you just put them on the forum and we will look to address them. Okay.
Awesome. Thank you, Christine. So we just have a few moments left here. There's one additional question about non-US citizen participation. So this question, I think I saw somewhere that I can waive the prize money and participate as a non-US citizen. Is that correct?
Yeah, I think I'd like Doug to answer that question regarding the relinquish rule on the contest rules. And Doug, if you could also elaborate on the number of days that the contestants can team, that would be great.
Sure, I'll answer the teaming question first. So you have up until the 21st day after the start of each match to create your team, submit the teaming form. The teaming form can be found within the problem statement, and feel free to use the forums to find or coordinate with teams to create your team or ask for additional team members. As far as relinquishing the prize, you can absolutely relinquish the prize and compete. Therese, from a payment standpoint, it doesn't really affect any of the rules for that, the legal issues. No, so all right, yeah. So yeah, if you're a non-US citizen, you can absolutely compete if you submit your intention to relinquish your prize. That's done by the forum. So you post forum post on there and submit that intent and compete.
Yeah, and I believe they'll be identified on the leaderboard as a relinquished contestant as well. And then let me just add also that the funding for this prize competition is from the America Competes Act, which was reappropriated in 2010 by President Bush. And those funds are really for science and technology. It's to spur innovation, and it's also to educate and increase and improve research and development, the competitiveness of research and development. So those funds are essentially funded by U.S. tax citizens, and so that is the reasoning behind the U.S. citizenship on the awardees of the prize.
I see we have one last question I just want to clarify before we wrap up. I had not mentioned this. These are randomized algorithms. When we do the final scoring, we're going to be running your algorithm multiple times and getting that average performance. We're not going to just run them once and then have suddenly have a Las Vegas game on our hands. So we understand the randomized algorithms. We'll be running them many times for that final evaluation to determine who gets the 5 big prizes. And we'll find out where your distribution of performance is. We'll find out how it changes with Epsilon. We'll have a good understanding before we decide who our top scorers are.
Fantastic. Thank you so much, Christine. And thank you to Therese and Doug for their participation. One last question.
One last one, and then
wrap it up.
Everybody who has suddenly great questions to ask, please just move right on over and ask them on the forum. And we're going to be posting the answers from these over on the forum too. I know probably some of you are super used to using forums, and some of them it's going to be something new that you don't usually do. But forum is going to be where everything will happen for this contest. So we'll be happy. I'll be there. Top Coder people will be there. We'll get your stuff answered. Is execution time of the algorithm being scored? Nope. We are not looking at that at all during this contest. If you have something that gives us memory errors at the end, we may have to have a little conversation to try and sort that out. But we are not going to try and look at that.
Great.
You want as slow as you want to.
Okay, so I see there's a few more questions coming in. I think what we'll do is if you have any outstanding questions, we'll take the ones that are still coming into the Q&A and we'll make sure we follow up and get you answers to them afterwards. And any other questions, like Christine said, please do post in the forum. That's on the Top Coder site. If you haven't yet registered on the Top Coder page, please do so. It's the best place to find the updated resources and information. And like we said, ask your questions. So with that, I want to extend a big thank you to everyone who joined us today. Really great questions. It made for an awesome discussion. And thank you, Christine, Therese, and Doug for your contributions today as well.
Thank you, Kyla. Thank you, everyone.
Thanks, everyone. Have a great rest of your day.
Thank you.
Bye.